Hey guys, so I was thinking quite hard how to introduce BabylonJS developers that are quite experienced with game engines to BitByBit, and I was thinking, and at the end I decided that the easiest is going to be just to open up the TypeScript editor that we have and just code a few things that might trigger you in understanding the relationship and how BitByBit can help you in certain types of 3D modeling applications that you're building. So let's just jump in directly from our homepage. You can click apps and go to Monaco, and Monaco is our TypeScript editor. It's the same that the BabylonJS playground uses, and now we've opened this empty editor, right? So I'll copy paste some code that you might be familiar with from the playground, and you see here things like Babylon scene. You see here free camera that we've created. You see the hemispheric light that we create. So all of these are familiar to BabylonJS developers. The things that you may not be familiar with is how to get the engine from BitByBit context, and the fact that you also need to inform BitByBit that you've created a new scene. Otherwise, we don't know that you did that, and then things would not work the way they should. So for camera, you need to also attach it to the canvas, and we get the canvas also from the engine by getting this rendering canvas that is active. BitByBit only has one rendering canvas, so you just need to use that one. And that's it. This is pretty straightforward, right? If we run this code, so you do that by clicking this play arrow, you see that our background turned to the default BabylonJS color. And so far, so good, right? We can even go ahead and do things like babylon.meshbuilder create box, and we can pass a name box with the size of 1, and we pass the scene, and we hit run again. You see that we have a cube. Because we have the free camera here, we can go around it with the arrow keys. And everything works as you would expect in Babylon Playground, basically, more or less, right? We don't have create scene function. It's a bit different, but in principle, it does work. BitByBit is a library that helps you create 3D models on the fly. It's a CAD library that opens up a lot of possibilities, integrates even few modeling kernels like JSCAD and OpenCascade inside of it. And we expose certain features that are most crucial to developers of various 3D configurators. We'll just get started by creating a boilerplate code that you usually see in BitByBit. It's a start function that is asynchronous, and we'll initialize it to the arrow function, and we'll call it like that immediately. We'll create now few points that we will draw on the screen, and I have prepared the coordinates for those points already, so I'll also just do it like this. So a point in BitByBit is just an array with 3 numbers, so we can just do it like that. And I'll actually say that it's a 0.3 type, and I'll define it here being 0.3. I'll use our default types, so bit inputs base 0.3, and if you hover on it, you'll see that it's just a number type. This prevents us from adding more numbers into these arrays like that. This will not be working, right? Okay, so we've created this array of points, and now we just want to visualize those points. And to do that, we'll go ahead and draw the points. And drawing happens in BitByBit by using this draw command called drawAnyAsync. So drawAny would also work for certain types of geometry that don't require any asynchronous methods behind them to be drawn. So points that would work because they are rendered by Babylon, but just to make sure that we use one thing in this tutorial, I'll just do it with drawAnyAsync, and you'll see that it works for many types of geometries. So I'll say that the entity that we want to draw is points, and it's a smart method. It recognizes that we want to draw the points, and that method will put those points on the screen, right? So I hit run now, and you see now we have 4 beautiful points in the environment. Let's go back to the code, and we see that we have 4 points, right? Important thing to realize is that draw methods return to you a Babylon mesh. And it's a promise-based approach. That means that it takes a while for BitByBit to compute that. Usually with points, for example, the computations are fast, but if you go to the cat kernels and you do various kinds of operations like unions, booleans, and everything, that tends to take a long time, and you must then make sure that you await on those methods. Thus, we promisify those things, and you see that we have now a result that is a mesh if we await on the method. So result is a Babylon mesh, right? You can then go through the children. In this case, we have a mesh that hosts instance mesh children for spheres that represent points. So BabylonJS developers probably are familiar with that concept, and yeah, this is what we use in this case. Another entity that we will create is a wire that goes through those points, and this is something already that probably BabylonJS natively would not be able to create. I'm not exactly sure, but bear with me, check it out. So let's create a constant called wire through points, and let's await bit by bit OCT shapes wire interpolate points. So this is a way to create wires, and we'll pass points. We'll say that this path needs to be periodic, which means that it will be closed path that loops around those points, and we'll give a tolerance of 0.01. Okay, so now we've created these points, and you see that this just gives us a top.ds wire pointer, which does mean that you are dealing with something that is an entity of OpenCascade, and to make it an entity of Babylon, you still need to draw it. So basically all those draw commands just take things that you put in, inputs, and turn them into something that you can draw and interact with in Babylon. And this, in this case, you will give entity a wire through points. You'll get back the wire mesh as a result. So we have here wire mesh. And if we hit run, you'll see that we've created a nice looking loop that goes around those points. These loops can go also through non-planar points, so you can do it like that. And just for clarity reasons, we'll create also something called a grid, and we'll use a helper function from bitbybit to do that. So grid options is new, and we'll pass those defaults as options to the method. So we hit run, and we see that we have this nice looking loop in 3D space. Okay, so we've created now this wire through points, we've created points, we drew them. In fact, we don't really need to await those methods. These are visualization methods. The only thing that we want now is control a little bit the color of those points that we've created and the color of the wires. For the points, we have to use options that are defined by this draw basic geometry option. So if you are drawing polylines or points or things like that, then you use those. So we use point options is new, and we want to make the points pink, so we'll use this hexadecimal notation, and we'll pass the point options here, and I'll create wire options as open cascade options. So this is due to the fact that Open Cascade geometries are represented by faces and edges, and there's just more things to configure on the Open Cascade entity side when drawing them. So wire options is wire options, and we can change the wire color by saying wire options.edge color, and that's just gonna be blue. Okay, so we hit run now, and we have our path now as blue and points as pink in our 3D environment. That's quite nice. Probably it's good idea to call this point draw options and this wire draw options to just not confuse ourselves. So another thing that we can do on this geometry is create an extrusion. This is now getting into something that in Open Cascade is called faces, and let's just go ahead and create the extrusion. Let's await, and let's go into bit by bit, Opacity again, operations, extrude. So we want to extrude the shape, that is the wire itself, and we want to use the direction that goes upwards. So I'll do it like that. So you see that the vectors and points in bit by bit are all just arrays with 3 numbers. That's for simplicity reasons. And if we hit run, yeah, nothing will happen. We still need to draw this result of the extrusion, and we'll just do it like that. We'll just go ahead and draw it. Okay, so here it is. We've created an extrusion, and one thing I want to do is put that point back to 1 so that the bottom face would be planar later. Yeah, this looks quite nice, right? We can use also options for our final shape. So we'll be now drawing wires, points, and always this final shape. So let's do final draw options. Let's copy paste it here. And let's use final draw options like that. Let's remove this. Let's remove that one. And I'll increase a little bit the precision of our mesh by using a lower number with this tolerance. Let's go ahead and create one. Now you see that the edges look a bit nicer. So this is what we want to see. And also we use backface culling so that we understand towards which direction the faces are pointing in Open Cascade. So you see here that we sort of have this face that is one-sided, and this is in fact actually what we want and expect to have in Open Cascade. So I'm not going in this video to details, and sorry for that, but I just want to run through the few algorithms that you can use and just point out the fact how those draw methods work, and the fact that you can just go ahead and parse these meshes at the end and just look into what they produce and experiment further. So let's go ahead and create further things that we want to do in this modeling session. And what I want to create is a base for this shape. So I'll create a face that will be done through this OST shapes command create, so from wire. So I want to use a wire again that goes through those points, and I want to say that it is potentially not planar, right? So currently it is planar, that face, that wire, but potentially it may not be. So let's do it like this. And also let's extract a face from our extrusion. So let's call it Extrusion Phase, and let's do it like this. Await bit by bit, Opacity, faces, first shapes, face, get faces, and we'll pass the shape as extrusion. So we have an extrusion phases, we have face, and I'll call it a bottom face. And now we'll create a shell. So you have edges, wires in Open Cascade, you then have faces, you then have shells, and from shells you can create, of course, solids, etc., etc. So now we'll do that shell, and you do that by using, again, our bit-by-bit command. So bit-by-bit, opacity, shapes, shell, and sew faces. So we pass the shapes that we want to sew, and these are the faces then. So we go and say extrusion faces need to be parsed, and a bottom face. And we want to use a certain tolerance. So if the edges of the faces don't touch each other, you know, you shouldn't sew them together. And if they do, they should be sewed together. Okay, so we have this shell now, and we can just draw it. You could have drawn also the face of the bottom, but I just skipped that step, and I just now going to draw the shell of the combined shape. So this is a shape that we have now, and it's a simple extrusion, right? Nothing special going on here, but it's just, yeah, free form that is quite beautiful. So let's go ahead, and we will now use some other commands like fillets to round up the edge that these two faces share. And to do that, I'll use the await bit by bit ost fillets and fillet edges command. So this command takes in the shape that we want to fillet, and that will be our shell, and it will take in the radius, and I'll say that the radius is 0.2. And now we'll just go ahead and draw that fillet. So we'll always draw the result of the computation. And now we click play, and you see that now we deviate a little from our original path because we did round the corner of this shape. So this is so far looking good, but you have to understand that this is not a three-dimensional solid yet. It doesn't have any thickness to it. It's just a shell. And to create a solid, you can use a nice command that is called make thick solid simple. So I'll do that. I'll say that we are creating a thick solid. I'll await bit by bit OCT operations. And I'll say that I'll want to use make thick solid simple, and I'll pass the shape of a fillet, and I'll say that the offset needs to go to the opposite direction of the face, so minus 0.7, and I'll draw the result on the screen. Let's hit run, and you see that now we have a nice looking solid shape that has a bit of a hole with a rounded edge. So we can also go a bit further away and see how that whole shape looks like, right? Because we use the thick solid simple command, you see that this was also rounded appropriately, and it's now offset by 0.7. We should in fact do -1 here, because our points are hanging on 1, 1, 1, and they represent the inner shell bottom. Okay, so we're done with that part. Let's do fillet thick, and let's await on bit by bit ost fillets, and let's use again this fillet edges command, where we will say that we want to fillet the thick solid, but we will pass radius list, not the radius anymore, because we want to say that we are going to round one edge with 0.1 and the other by 0.4, and we'll pass the indexes, and these I know by heart, so these will be 3 and 7. It's because I prepared for this tutorial. usually you need to figure out yourself which edge represents which one on your geometry, and there are ways to do that, but this tutorial will just skip that information and just continue on the other videos to learn about those things. Okay, so we have now this fillet thick, and let's draw it, and let's hit run. And now you see that the top two edges were also filleted. So this is quite nice because you can then tweak the things that you want on the shape. And yeah, this looks quite nice, right? You can then also decide that you don't like it to be 0.4, maybe it needs to be lower, 0.2, and you run this algorithm again, and you get this nice looking shape again. Okay, so now we have our original points hidden, so what we can do is just say final draw options, face opacity, let's use something like 0.8, let's hit run again, and you see now that we have our end result, we see our original points, we see the wire that goes through those points, we see the extrusion that was created and fillets that were made along the way that we created the shape. So this shape also can be exported as STL or step file. It can be imported to other CAD systems like Inventor or FreeCAD or Rhino and modeled further. You can also choose to export STL and just put it onto a 3D printer and slice it in Cura or something. So these shapes are real CAD geometry. So another last thing I wanted to point out is that you can put those points to a non-planar position, and you do it by just increasing the Y direction, right? This will just lift them up. The only thing that we have to fix is this planar thing that has to be false then, and the bottom face needs to be adapted to it. So we hit run, and the geometry recomputes. Maybe let's not use this opacity. Okay, you see now that the shape flexibly adapts sort of by going and filling the requirements. Okay, so this is quite exciting, I think. Feel free to explore the script by saying that, okay, you want to inspect maybe the drawn mesh here. You will probably need to get your children. You can check the children for what they contain. So probably for the edges, you'll see some line meshes that are being created. For faces, you'll see face meshes, and you can then apply various materials from Babylon on top of them. So feel free to experiment. I hope this tutorial was interesting and you've learned at least fundamentally how BitByBit can be used to create geometry. So this is not a very deep introduction or anything. It's just to show you the possibilities, walk you through some methods that we offer. And of course, to learn deeper concepts, you'll have to follow other lectures probably. Let's see each other in the next videos. Cheers, guys.